Hello everyone, welcome back. So, let's try a group problem. So, grab a friend, grab a rubber duck, grab a teddy bear, whatever you have nearby, grab it, and work on the problem together. Hopefully it'll be helpful, if they won't. So, we have a part. Looks like this. Now we're trying to find the centroid of this part. Now it's a two-dimensional problem, so a little bit easier this time. What's our plan? Follow the steps. Follow the steps for analysis. Make that table, write it all down, and you'll be surprised at how easy it is to solve. Just remember, little gaps like this, those count as negative area. Negative area. Okay, so with that being said, go forth. Try it on your own, and then come back and see how you did. So, 3, 2, 1, and you're back. So with that in mind, let's keep going forward. Okay, so this time we divide it into a triangle, a square, a quarter of a circle, and a half circle. All of these shapes you can find their centroids, and a lot of different stuff about them in your book. You have to use a negative sign for this. So what we're going to do is we're just going to walk through it step by step and make that table. Boom, it's done. Okay, let's actually walk through it. The areas aren't that difficult. Area of a triangle, 1/2 base times height. It's 3 inches tall, 3 inches wide, 4.5. Rectangle, fairly simple as well. Quarter of a circle, pi r squared. Pi r squared is a quarter of a circle. What is its radius? Its radius is 9. That's the pi r squared right there. Now we're dividing it by 4. This one, pi r squared, but the radius is 1, so we don't see a 1 there. Over 2, but it's a negative area because it's a whole. We add all these together, we get the total area. Then where are their centroids? Well, we're always going from the origin in this particular case to x squiggly and y squiggly hat. For a triangle, that is a third of the way from the base, or a third of the way from the bottom, which direction we want to go. So it's 1 in the y direction, and it's 1, 2, 3, 4 in the x direction. Also, it's a negative 4. Sign does matter. Rectangle, just right there in the center, so 1.5 and negative 1.5. For a quarter circle, this is a bit harder. You need to look this up on in the textbook. As you can see right here, it's 4 times r over 3 pi. Like, what in the world? You don't have to figure it out. You can just literally look it up. I would suggest you do so. For the semicircle, and the x direction is 0 because this axis cuts it directly in half. We can know that the x squiggly hat is along the line of symmetry. And similar for this one, 4 over 3 pi for the y direction. Okay, then we multiply them all together and we add them. So we have our total area, we have our total x squiggly times a, we have our total y squiggly times a, and then we go forward and we solve. So area xa, ya, we divide them to get x bar and y bar, and we see that it's going to be negative 1.18 inches and 1.39 inches. So somewhere around there would be our centroid. Now this process doesn't change. It's the same every single time. So if you follow it carefully, you'll never get these kinds of problems wrong. It's when you go outside of the process, then you start having issues. Other issues people usually have are they forget. They forget that this triangle right here is not right next to the origin. Doesn't work then. I have to say, if I'm going to try to find the centroid of this little triangle, okay, well, it's, somewhere around there, a third of the way from the base in either direction. But then I have to add the distance to the centroid. Don't forget that. It's very helpful. Well, I'm going to stop here for now, and I'll see you all next time. Thanks for watching. Have a great day. Bye-bye.